So, welcome everyone for the last talk in this room. We're going to find out how to tackle complexity around the heart of your service. So please welcome Mattijs Meiboom.
Okay, so thank you, Andreas. Hi everyone, final talk of the day about test complexity, and it's a bit of a story out of experience. Let's see if the clicker picks it up again, or if I have to be more. It was working, of course. Very nice. I'll give it one try, and otherwise, okay. Okay, we'll have to do it like this. No worry. Haha. That's yes, worry. There we go. Now we have a clicker. Yes, there we go. Okay, fine. So I'm Mattijs, software engineer within the logistics space. And I gave a talk 2 years ago about some architectural design about a new service we started. And I did get some questions afterwards about the topic itself, and had some nice talks there. But the question I got most was that I talked about that I read IT books on holiday. And every time I get back from a holiday, people ask me what book I read. So that's also a nice outcome. And I went on a holiday, I got back last week. And I have been reading again. Yes, so, but not an IT book. I've been reading fiction. For those who don't know this series, I can highly recommend it, both the book or the Netflix show. But there's some cool quotes in there, and I just had to share this one coming back to work. And it's a nice quote, I think, in general, but when I read this, I was thinking not of the book itself per se, but more about, this reminds me of working on software. Everything is connected, and everything changes, and something else changes, and mostly the software you wrote a year ago, right? Not the stuff you wrote recently, which is usually much more easy to follow. Anyway, just wanted to share that. If you're a fan of Hitchhiker's Guide, this one is highly recommended as well. But for today, why we're here, I want to talk a bit about something that's in line what I talked about 2 years ago. That was about software design architecture we use in one of our services. But I didn't cover the testing part that much. And we're 2 years ahead now. We've been doing a lot of innovation on that service. And we got into some problems at some point. I think there's an interesting thing to share there, how we dealt with those problems and how that actually helped things get better a bit. Now I mentioned architecture, hexagonal architecture, and I'm not going to do the same talk of last 2 years ago, because then I'm out of time. So I have to do it in like 2.5 minutes before we dive into today's topic more. So hexagonal architecture. It's a way of structuring your system that especially focuses on separating the domain, the business logic, from the technical parts, your infrastructure. Commonly referred to also as ports and adapters. I'll come back to the why of that. And it's very often used together with domain-driven design because of this real big focus on the domain part. So you have a domain and a mouse cursor inside. Yeah, there it goes, which contains the functional part, your business logic, your entities, behavior of your application. Outside of that, there we go, you have your technical parts, infrastructure, which does not contain any business logic at all. It's just technical. And the core thing here also is that the domain has no knowledge whatsoever of the technical parts, right? You only focus on the behavior and the business rules of your application. Now, the way those parts interact is by having a domain define interfaces, like a use case, a method in a Java interface, usually called a port. Your business logic can define what it needs from outside to actually fulfill its purpose. And you usually have then adapters implementing or using those interfaces to expose that behavior to the outside world. So, for example, HTTP request comes in, you have some adapter, maybe some Spring Boot controller, translating a JSON body to a domain object, which then feeds into your business logic, does your magic. Maybe it needs some entity from a database, so you also have defined an interface for that, and some maybe Postgres, JDBC kind of implementation that can provide that entity. Even got 40 seconds left. Awesome. Okay, so that saved me some time for the end. But besides the way this helps you to separate technical and functional parts. For example, we were able to change out the database over time to upgrade versions of box events we had to listen to without worrying whether it got impact throughout the entire application. Those parts are typically very isolated. It also provides an advantage in testing. And that's because of the boundaries we saw before. So this is a bit more elaborate schema. You have your business domain, and that's basically the boundary of your business logic. So if you're doing any acceptance testing or feature files like a Cucumber, you have very easy predefined ports of entry, and everything inside that should be able to support that business case. Being more specifically, unit tests, whatever you want to do, any complex parts you think you should focus on extra, you can still do. That's more out of scope for this, this talk. But functional tests, like Cucumber, you have a very strict boundary, which you talk against. You may have to need some mocks. And integration tests, where you want to test the whole system. So some you may want to do in isolation, but the cases where you really want to exercise your whole system, you also have, again, a very outside boundary, which is specific. You use your HTTP test client maybe, you have some dependencies mocked out, but the rest is all very well defined on where you should put what focus. So, and it works very well for us. Big disclaimer, I say we a lot. I'm no longer part of the team where we applied this. I'm actually working on shutting down LSM, and as Huub mentioned this morning, this year it will really be shut down. I'm hoping that's not the only highlight of this. Anyway, but we did get a lot of advantage out of it. But when we started, it was replacing existing stuff. We knew where we were going. There was no huge backlog of business wishes because we've been saying like 2 or 3 years, we're not going to do any innovation anyway because we have legacy, LSM, we can't do that. But once we got it detached, the new wishes got piling up, and we started building new stuff, and we started innovating, and it got bigger and bigger and bigger. And while the functional part worked out very well, it slowed down at some point while we just kept on innovating. And at first, we were just fighting against the flow. So tests got slow. The hardest part with every change was getting things to work again, to find out why this test interacted with that one. And the situation we were in, and I've rephrased the quote a bit this time, is that every test actually seemed to affect or be attached to the other ones in some miraculous way. And it was fine as long as you knew how it was connected to the other test. But usually we didn't. So yeah, we got stuck there. And at some point think, okay, why is this happening? I mean, there's a lot of ideas you can apply, a lot of patterns to isolate tests from each other, but there was some bigger conceptual problem here. And to show that, I want to go through an example. One of the things we added at some point, return on demand, so we can pick up your parcel at home. It keeps going double, fine. Which is available for select members under certain conditions. Not everyone can use it yet. So a typical scenario would look like you need to have a shop order. It has to be shipped. It has to be shipped specifically from Ingram Micro. Oh yeah, you should be living in the Netherlands. Otherwise, we don't have a transporter for this service. You have to have a select subscription. It has to be active. You have to live at an address that we can actually have a transporter pick up the object. So Texel or one of the other islands, no go. And then, and only then, you can make use of this service. And so these entities, all these things you need, are all outside of the returns domain. I mean, they're services by different teams, different parts of logistics mostly. So on the one hand, we have our domain, we have our business logic. On the other hand, we have all kinds of state we need to test this functionality. So a test would typically instantiate that state. There we go again. Then you need some way to actually make sure that your domain can make use of that state, which goes through a mock, usually, if you're testing in isolation. and then you exercise your business logic and see what happens. Now the problem here is that your test has to set up mocks, and the number of those mocks and the way they're isolated from each other, because they're separate services, separate teams, determines complexity. So what we did was isolate our business logic. We created a layer of ports in between, a layer of indirection, which shields it from all the technical changes, which is perfect, but it also creates a distance between our domain and between all the other state outside of our service. And then we said, okay, test, you want to test stuff, but you have to do all the mocking as well. And then every test again and again and again and again. And there's ways to make it simpler, but still it was a burden. Love this quote, very applicable when I was reading this again, which is way before we started doing microservices, but mentions very well one of the problems we have a lot at Bol.com, I think. It basically says you can divide a process, a business process, in many services and many subsystems, but it becomes so much harder to test the process as a whole, and the pain is in the integration. So that's similar to what we were expecting as well. In an ideal world, I would say, the way we separated that stuff is an implementation detail. Your business owner doesn't care if you're using one service, 20 services, how they work together. It's just about state and behavior. And your test shouldn't be aware of that anyway. If you're writing it like a feature file, try and stick close to that domain logic, to that domain-driven design you might be doing. So we needed a solution there. So how did we solve that? We didn't, to be perfectly honest. This guy did, from a completely different perspective, but Mikola gave a talk maybe one and a half years ago about something he was doing with testing, and something clicked like, okay, wait, this is probably a perfect way for us to apply and see if this helps us out. So this is also why sharing all those cool ways of how you're approaching your engineering helps your fellow engineers, in this case, us, very much. Again, we have our own context on the left. We have all the other state outside of our service on the right. We have a test. Right, and we say, okay, let's just prepare some state. Let me check how I'm doing on time. Oh. No, okay, never mind. So the test prepares some state, and it's all functional. I'm just saying I have an order item, and I'll have this object keep track of its state. For details, I'll have references at the end towards reference implementation as well. So then your test can just manipulate that state. There's no direct mocking going on here, right? You're just saying, I want an item, I want it to have been shipped, I want a reference to the customer with a subscription, and then I do my assertions. So then we still need something in between there, something magically being able to say, whenever this mocks get called, I should look at this state and translate the response and everything, but without any relation to the test itself. Which is where, in case you're using Mockito, but other test frameworks have similar things, we used something called a supplier or an answer, which is functional interface in Mockito. Just the highlights here are that you only bind a port, so something you defined as on the boundary of your domain. We bind it to a mock. Whenever this port gets invoked by the domain, come to me. I have this function, which is a lambda, and that function has access to the context, and it's able to just look into the context and say, okay, you asked for a shop order item with this ID, let me look it up, it's there, okay. It gives back the object. It's not very different, maybe, but there's one major advantage here, which is that your test doesn't have to, in any way, keep itself busy with this setup. You do it once at the beginning of your test run, and from that point on, it's just straightforward translating. The reason that it is pretty straightforward is also a result of the design choice that your technical layer should not contain any business logic. It should be straightforward translation between maybe JSON and a domain object. So those kind of translations should be simple anyway. If they're complex, then this becomes complex again also. So there's a bit of a limitation. So what it looks like in the end is that there is a specific class that deals with making sure that each port has a function being able to map the context to the domain. Again, for details, I think Mikola has a repository of this, and we have a combined reference implementation for hexagonal architecture using this way of testing as well. And it works also for integration testing in case you're using WireMock at least, which has something called transformers, and it can do the same thing. So you can think about this protobuf interaction with your service, or maybe some resilience testing, stuff like that. I'll skip that one. So looking back a bit, as mentioned, we didn't solve this ourselves at the time. Reflecting now on how this really helped us to make things a lot smoother in development. The main lesson for us was to, when you keep on fighting against these little things, or seemingly little things, and they cost a lot of time, just stepping back a bit and revisiting that choice you made almost 1.5 years ago of we'll go with this architecture, with this design, because we think it helps us test, because we think it helps us innovate fast. Revisit those assumptions. Are they still true? In what way are you having maybe problems on a more conceptual scale? And then, well, can you then solve them? Which in this case turned out we chose to really separate business from technical. So why are we constantly fighting with technical details in our tests? And the click there was we shouldn't even be having those details in our test. Again, there's a lot of great material online on the design itself, as well as some implementation. If you're interested, ask me, or look it up yourself. And I think I haven't seen any time things, I probably completely miss it. There you are. I think we have time for questions, right? We have plenty still? Great, and I can show some more details if anyone wants. But let's start with questions, I think. Yeah, thanks. So, any takers? I'm completely in the back. I don't know if you need a mic, but let's see, otherwise I'll... Okay, yeah, so the difference is not so much in the testing framework we used. Before it was also Mockito. The difference is in who you make responsible for the mocking, at what point you do that, how you deal with the problem that typically what we used to do in mocking or in testing was think from the perspective of, oh, I have to prepare this mock and this mock and this mock, and I have to get some state. We turned that around. We said, okay, no, for this feature, this is the state from a business point of view, and then make sure that that gets translated back to an appropriate response of your mock. And using not the regular way Mockito does that on a method level, but instead binding a function that can do that dynamically at the point it gets hit. So that's the main difference that clicked for us. But using a different testing framework might have similar way of doing that dynamically. Oh, I saw a hand over there. Yeah.
I was on the first hand, but I haven't. So you're basically talking about a test DSL for state preparation, right?
Yeah, so that's another benefit. Since your external context, and now I'm gonna try and summarize Mikola's points there, because that's only concerned with your domain objects. You don't have to think about the technical details there yet, because that's separated. You can make it a fluid API for it. Oh, I lost it again. Okay, cool. So it's just Java objects. So you can use builder patterns if you want. You can use what we do, just try to have the most natural way of phrasing things. So there's a lot of methods in each external object. You have a customer with a method that has an active select subscription, something like that, something you would probably say in a discussion as well. And then the details are later.
But I haven't gotten to the question yet.
Sorry,
So,
wow.
What I wanted to ask was, aren't you essentially duplicating complexity from in external dependencies? And aren't you afraid that you're gonna front load yourself with future work when your dependencies changes?
In the sense you mean that we are doing mappings for them, or in what sense do you see duplication?
You kind of touched upon this when you spoke about it. You don't want any complexity in your technical layer, but still you're doing a mapping from your local domain objects to what external services they talk to, and like that's code, that's logic that I guess also needs to be tested. And I'm wondering about, did you run into the risk that extra complexity brings?
There is a risk, agreed. But what we did here usually was there's kind of two things going on. If we really want to test the mapping, for example, from a response from the shop order service, and mapping that to the domain, which is a single class being responsible for that, write a unit test for it. It's just so isolated, cohesive. At one point, we wouldn't use this whole test harness for it. But at the same point, we do want to test the interaction between all these different ports we're hitting in one use case, how they work together. So what we would do is grab a response from the test environment or from production, ideally, depending a bit on the service. Use that and only the fields that you're really interested in to make a consistent response for that service to your domain. So we use a lot of defaults in those external objects or just a template response and leave the really specific tests on mapping to a unit. Right. Is it clear enough? I can maybe afterwards show you some actual code in detail.
Oh yeah, it's fine. Cool.
Okay, any final questions?
Have you considered... Yeah, so did you consider not using a mocking framework at all, but for instance, I saw this order service, have it as an interface, and then actually building a mock implementation of it, which just, serves the responses that you want, instead of, going deep into Mockito, for instance?
You mean more like a stub implementation then, or?
Yes.
Yeah, so we did use some kind of stubbing at some point. The problem you run into, and you mostly run into that when you're testing the system as a whole, is that even though we decided some arbitrary, more or less, split between all these teams and all these services, there is some consistency going on there. So I can indeed say we have all these pre-recorded responses for a shop order, and maybe have 3 or 4 types, and then have all these pre-recorded responses for shipments and have a couple of types, but they need to be consistent with each other. So you have to do a lot of stuff with references, IDs, things like that. And then changing becomes very difficult. So if you want to change your test case just to slightly different business rule maybe, you have to look at the whole consistency of all those stubs. While in this case, we can add one extra field to the external state, which does have all those references to the objects, and then we may have to adjust 1 or 2 of those functions that do the mapping. But that's dynamic again, which makes especially the referential integrity a lot easier in the experience we had. Okay, see no more hands, so thanks again for listening. I think we're all off to the big room again.